Hello everyone. Today we will discuss about the canonical transformations. In many problems, one set of the position and momentum coordinates is need to change into other set of position and momentum coordinates. As you have seen earlier that the Cartesian coordinates can be transformed into polar coordinates, into cylindrical coordinates, or into spherical coordinates. Similarly here, the old set of the position and momentum coordinates can be transformed into new set of the position and momentum coordinates. Let us say qk and pk are the old position and momentum coordinates, and capital qk and capital pk are the new set of the position and momentum coordinates. Now we can write the transformation between the old coordinates and the new coordinates as capital pk is equal to pk. It is a function of the old position and momentum coordinates and time. Similarly, qk is equal to qk, and it is also a set of the position and momentum coordinates of old coordinates. Let us say it is equation number 1. If s dash in new coordinates is such that pk dot is equal to minus del h dash over del qk, and qk dot is equal to del h dash over del pk. Let us say these are equation number 2, and here h dash is also equal to sigma k is from 1 to n pk qk dot minus l dash. Let us say it is equation number 3. Here, if l dash is substituted in new Hamiltonian principle, then delta t1 to t2 l dash dt equal to 0. It gives the correct equation of motion in new coordinates qk and pk, and these transformations are called as the canonical transformations. Earlier, if you remember that when we were discussing about the old set of the Hamiltonian coordinates, and you know that small pk dot was equal to minus del h over del qk, and qk dot was equal to del h over del pk, and the Hamiltonian was there equal to sigma k is from 1 to n small pk qk dot minus l. Now if L satisfied the Hamiltonian principle, then we can write here delta t1 to t2 L dt equal to 0. So those equations are called as the Hamiltonian canonical equations. So similarly here, in new set of the coordinates, these are pk capital pk dot is equal to minus del h dash over del qk, and capital qk dot is equal to del h dash over del pk. These are the Hamiltonian equations in new set of the coordinates. Now we will discuss about the generating function. For canonical transformation, the Lagrangian L is defined as it is a function of the small qk and pk. Similarly, L dash a is function of the capital qk and capital pk in new set of the coordinates. Now these must satisfy the Hamiltonian principle. In old set of the coordinates, we can write delta t1 to t2 L dt is equal to 0, and delta t1 to t2 L dash dt is equal to, this variation is in new set of the coordinates, and this variation is in old set of the coordinates. So we can write L is equal to sigma k is from 1 to n pk qk dot minus h, and L dash is equal to sigma k is from 1 to n pk qk dot minus h dash. Let us say these are equation number 6. Now from equation number 5 and 6, we can write as delta T1 to T2 sigma k small pk qk dot minus capital H minus sigma k capital pk qk dot minus h dash dt is equal to 0. Because in equation number 5, we know that L is equal to, from equation number 6, it is sigma k is from 1 to n pk qk dot minus h, and L dash is equal to sigma k is from 1 to n pk qk dot minus h dash. So we can write from equation number 5 and 6 as equation number 7. Now if we write this as the function small f, then we can write delta f dt is equal to 0. In general, we can write small f is equal to df over dt, where f, capital F, is an arbitrary function. So we can write delta t1 to t2. In place of f, we will write df over dt. So df over dt is equal to 0. And we also know that df over dt is equal to L minus L dash, because df over dt is equal to sigma k is from 1 to n small qk dot pk minus h, and L dash is equal to sigma k qk dot pk minus h dash. So we can also write as df over dt is equal to sigma k pk qk dot minus h minus sigma k capital pk qk dot minus h dash. Let us say it is equation number 8. Here f is known as the generating function, and you can see that it is a function of 4n plus 1 variables. qk, pk, these will represent the 2n variables. Similarly, capital qk, capital pk, these will represent the 2n variables. T is 1 variable. So total variables will be 4n plus 1 variable. But for transformations, it is important to note that f is considered as a function of 2n plus 1 variables. So f can have a time coordinate and any 2n coordinates from the set of the old coordinates qk, pk, and new coordinates capital Qk and pk. Because f can be written as a function of 2n plus 1 independent variables, so f can be represented into 4 forms, and these are f1, it is a function of a small qk, capital Qk, and t. f2 may be small qk, capital Pk, small t. f3 is small pk, capital Qk, and time. And f4 is small pk, capital Pk, and t. Here you may note that there is one coordinate from the old set of the coordinates and other coordinate is from the new set of the coordinates, and time is common in all the functions. Now we will discuss these functions one by one. Now let us say that our first function f1 is given as f1 q1 q2 qk qn, capital Q1, capital Q2, capital Qk, capital Qn into t. Let us say this is equation number 1. Now we can write df1 over dt as sigma k del f1 over del qk, qk dot plus sigma k del f1 over del qk into qk dot plus del f1 over del t. Sigma is here taken for small q coordinates, and this sigma is here taken for capital Q coordinates. Let us say it is equation number 2. But we also know that df over dt is equal to sigma k pk qk dot minus h minus sigma k pk qk dot minus s dash. So We can also write here that df1 over dt is equal to sigma k small pk qk dot minus h minus sigma k pk capital Qk dot minus h dash. Let us say it is equation number 3. Now if we subtract equation number 2 from equation number 3, then we can write it as sigma k pk minus del f1 over del qk dot minus sigma k capital Pk plus del f1 over del qk into qk dot plus h dash minus h minus del f1 over del k is equal to 0. Or we can write the earlier equation as sigma k pk minus del f1 over del qk into dqk minus sigma k capital Pk plus del f1 over del qk into dqk plus h dash minus h minus del f1 over del t into dt is equal to 0. Let us say it is equation number 2. Now as you know that f1 is a function of the small qk, capital Qk and t, and these are independent variables. So we can write it as pk. Here we will write this as 0. So pk will be equal to del f1 over del qk, and capital Pk here will be equal to minus del f1 over del qk, and h dash minus h is equal to del f1 over del t. So these equations are called as the transformation equations. Now if the function f is equal to f2 small qk capital Pk and t, then from the Lagrangian transformation we can write the function f2 in terms of the function f1 and a new set of the coordinates as. So f2 is equal to small qk capital Pk into t is equal to capital F1 small qk capital Qk into t plus sigma k capital Pk capital Qk. Here you may note that which term is common is not written here. The other terms for the coordinates except the time are written here. So it is plus sigma k Pk Qk. Now we also know that df1 or dt is equal to sigma k pk qk dot minus h minus sigma k pk qk dot minus h dash. Let us say it is equation number 2. Now we can write this equation as sigma k pk qk dot minus h minus sigma k pk qk dot minus h dash is equal to df1 over dt, and from equation number 1 we can write f1 is equal to f2 minus sigma k capital Pk qk. So we will write here in place of f1 the value of f2 minus sigma k Pk qk. Let us say it is equation number 3. Now df2 can be written as sigma k Pk qk dot plus sigma k qk Pk dot plus h dash minus h, because if we differentiate d over dt pk qk, then it will be sigma k pk qk dot plus qk pk dot. So this term, so one term here will be cancel out, that will be this term. So we will have here df2 over dt will be sigma k pk small qk dot plus sigma k qk pk dot plus h dash minus h. Let us say it is equation number 4. Now we also know that f2 is a function of qk, pk and t. So if we differentiate this with respect to time, then we can write df2 over dt is equal to sigma k del f2 over del qk into qk dot plus sigma k del f2 over del pk into pk dot plus del f2 over del t. Let us say it is equation number 5. Now if we compare equation number 4 and 5, then we can see that small pk is equal to del f2 over del qk, and capital Qk is equal to del F2 over del Pk, and H dash minus S is equal to del F2 over del T. Now the if third function f is equal to f3 and it is function of pk, qk into qk and t, then f3 can be written as pk qkt is equal to f1 qk capital, it is qk capital qk t. Here we will subtract the term sigma k pk qk. Here you see that the term which is common here is capital qk and p, so we will not write these terms. So here we will write small pk and qk. So here we will subtract small qk and small pk. Let us say it is equation number 1. Now here f1 can be written as small qk capital qkt is equal to f3 small pk capital qkt plus sigma k small pk qk. Now if we differentiate this equation with respect to time, then we can have sigma k pk qk dot minus h minus sigma k pk qk dot minus s dash, and this will be equal to d over dt f3 plus sigma k qk pk. Let us say it is equation number 2, because we know that df over dt is equal to, it is your term L and it is your term L dash. Now df3 over dt can be written as minus sigma k pk dot qk minus sigma k capital pk qk dot plus h dash minus h. Let us say it is equation number 3. Now as you know that f3 is a function of a small pk capital qk and t. If we differentiate this with respect to time, then we will have sigma k del f3 over del pk pk dot plus sigma k del f3 over del qk into qk dot plus del f3 over del t. Let us say it is equation number 4. Now if we compare equation number 3 and equation number 4, then we can have small qk is equal to minus del f3 over del pk and capital pk is equal to minus del f3 over del qk, and h dash minus h is equal to del f3 over del t. Now the fourth transformation is that if generating function is of the form small pk capital pk and t, then we can write f4 as small pk capital pk t is equal to f1 small qk capital qk small t plus sigma k capital pk qk minus sigma k small pk qk. In the first, when we use the f2, we have add this term, and when we use f3, then we add this term. So in the f4 generating function, we will add these two terms in f1. So here we can write df4 over dt as df1 over dt plus d over dt sigma k pk qk minus sigma k small pk qk. Let us say it is equation number 2. Now we can write these equations as sigma k pk qk dot minus h. This is your L and this is your L dash. So it will be equal to d over dt f4 minus sigma k pk qk plus sigma k small pk qk. Or we can write the above equation as df4 over dt is equal to minus sigma k qk pk dot plus sigma k capital qk capital pk dot plus h dash minus h. Let us say it is equation number 3. Now as f4 is function of small pk capital pk and t, so we can write df4 over dt as sigma k del f4 over del pk into pk dot sigma k del f4 over del pk into pk dot plus sigma k del f4 over del pk into pk dot plus del f4 over del t. Let us say it is equation number 4. Now if we compare equation number 3 and equation number 4, then we can write here qk is equal to minus del f4 over del pk and qk is equal to del f4 over del pk. S dash minus s is equal to del f4 over del t. Now we can remember these generating functions as here you can note that in the first quadrant we will use the f2, in the second quadrant we will use f4, in the third quadrant we will use f3, and in the fourth quadrant we will use f1. Now you see that when we find the canonical transformations, our first relation will be that del f1 over del qk, that was equal to plus pk. So this is your plus sign. Then our next relation was del f1 over del qk, and it was equal to minus pk dot. So here the minus sign is used. Similarly, for the other generating functions, we can find. Similarly, for f2, we can see that del f2 over del qk was equal to pk, small pk, and del f2 over capital del pk was equal to capital qk. Similarly, for the f4 function, we know that del f4 over del pk was equal to minus qk, and del f4 over del capital pk was equal to capital qk. Similarly, here for f3, we know that del f3 over del small pk was equal to minus qk, and similarly del f3 over del capital qk was equal to minus capital pk. So from this diagram we can remember the canonical transformations and the generating functions. Here you see that your first generating function is f1, and it is a function of the small qk, capital qk and t. Then the second generating function is f2. Here we will change the new set of the coordinates only. Here position will be converted to momentum coordinate. Similarly, for the third and second quadrant, we see that the momentum coordinates are same, pk and pk, but here you can see that the new position coordinate is converted into the new momentum coordinate. So see here, capital QK is converted into here, capital PK. So we can remember like this, these generating functions and their Hamiltonian canonical equations. Now bilinear invariant condition. If a transformation QKPK coordinates to capital QKPK is canonical, then its bilinear form can be written as sigma k delta pk dqk minus delta qk dpk. It will remain invariant. It means that in old set of the coordinates, it will be same as the new set of the coordinates. Thank you.